How to expand binomials in higher powers. We can still use the FOIL rule, which gives the two expansions, to find how to expand higher power binomials. For example, we can expand a binomial in the fourth power in the following way. We have the following shown on screen. The expansion of a binomial, when raised to the fifth power, is even more challenging. We have the following shown on screen. As you see, the more the power of a binomial increases, the longer the expansion procedure becomes. Therefore, it is necessary to find an alternative method of expanding binomials raised to a given power. In fact, the problem is not the value of powers, as you may see from the examples that the power of the first term decreases by 1 when moving from left to right, while the power of the second term increases by 1 during the same procedure. The main challenge to overcome in this respect consists of the value of the coefficients preceding each term after the expansion. In other words, it is already clear that the general form of a binomial raised to the nth power, we have the following shown on screen. Where C1, C2, C3, Cn-1 and Cn are the coefficients preceding the corresponding terms of the given binomial after the expansion. From the examples discussed earlier, it is obvious that C1 and Cn are always 1 regardless of the power of the binomial. The first scientist who found a solution to this issue was Blaise Pascal, who proposed his famous triangle, Pascal's triangle, for finding the binomial coefficients, which we will explain in the following part of this tutorial. That is all for lesson 12.3.2. To continue this tutorial, please watch 12.3.3, using Pascal's triangle. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.